Hello, Internet. This is 4090, or what's left of it. Can something like that be repaired? I don't know. I've never done this type of repair before, so all I can say is, I'll try. I wonder if I can salvage this from just any donor board, or maybe I can take that identical card to hopefully increase our chances with this repair. We'll see. The most important question at this point is whether or not the core itself is working, so let's check for resistances before we do any work. As expected, 12 volt is short, these 4 coils are memory, which is looking good, these two are 1.8 and 1.2, PEX is good, and no short on the other 12 volt lines. Okay, I think we have a chance. But I'll do check the data lines just in case. Who knows? They might be fried. Everything is looking promising, so let's deal with the burn. The damage is removed, and before I chop off the donor board for a piece, let's check and see if the short is gone.
The short is gone.
Let's power this thing and see what it does. Nothing. And no wonder. The main 12 volt rail simply does not exist at this point. Before I start the reconstruction process, it would be nice to know if the card is working at all. So I will simply jump the 12 volt into the card using a wire, so I can test it if the voltages, or maybe even a picture, will present itself. Who knows? We have all voltages, which is great, so let's go ahead and boot the card and see if it outputs anything. Nice. We have a picture. I even managed to boot into the Windows and ran a short test, which, if you notice, says that we have 0 watt coming from the PCI Express slot. That's not true, but there's a reason for that. In any case, what I'll do now is to solder this coil back on an angle so I can fit this fuse in there. So next time the card decides to blow itself up and set itself on fire, this fuse should help to prevent that. Hopefully. And that's what we have so far. Next, I'll mark the area of the donor board where to cut, and I'll be using the saw that came with the kit. Let's see if that works. And after using this junk saw that was made from Chinesium, I decided to simply break it off and file the edges. Something like that should do the trick. Not knowing exactly how to hold anything together, since I have not done this kind of repair before, I thought I would hold everything together by the riser itself, but that didn't work. So I decided to take these 2 pieces of steel with the pre-drilled holes in them and then just clamp them together, effectively creating a mini clamp. Because we don't want any traces to touch each other, I will mask them off on both sides, and then my plan is to solder something strong on top of this mess, and then fill in the gap with the epoxy. With that out of the way, let's boot the card and check if the PCI Express slot is now reporting power consumption. And as you can see, it does. Great work, everybody. I think we got a winner. All that's left at this point is to fill in the gap with the epoxy, cover it up with the mask, and that's what it looks like. Ugly but functional. What do you guys think? Let me know in the comment section below. Later, one of our technicians in the Discord group suggested that I may have missed one important connection on the back. The very first pin, that I completely forgot all about, is making its way all the way to the front of the board, through the capacitor, into the resistor, and then ground. Lack of this connection could prevent this GPU to be detected on some of the systems, so it's best to fix that. One way to do that would be to run a wire across the entire board, but I was told that all I need to do is to ground that connection like so, and that should be it for this repair. Hopefully you learned something today, and if so, please hit me with a like, subscribe for more repairs, and don't forget to comment below. Goodbye.